Hello, my phenomenal pre-calculus class. We are ready for another online adventure. Today we will study the sum and difference formulas, or they might be called identities, for sine and cosine. And the section is chapter 7.2. These formulas will simplify many trigonometric expressions and equations. Let us look at the formula for the sum formula for cosine. Sum, you see the addition right here, are two angles. So cosine alpha plus beta is equal to cosine alpha times cosine beta minus sine alpha times sine beta. The difference formula for cosine will be cosine of alpha minus beta equals cosine of alpha times cosine of beta plus sine alpha sine beta. Now let's look at an example. We're going to find the exact value of cosine of 5 pi over 4 minus pi over 6. And since it's minus sign, we're going to be looking at the cosine difference. So here's the formula. Again, cosine alpha minus beta equals cosine alpha cosine beta plus sine alpha sine beta. I then substitute, you see here, the alpha is 5 pi over 4, the beta is pi over 6. So I substitute in for alpha, 5 pi over 4, and for beta, pi over 6. I do the same thing over here. For alpha, 5 pi over 4, and for beta, pi over 6. So it's going to be something times something plus something times something. And then you want to go to your unit circle. And when you look at your unit circle, you're going to find 5 pi over 4, which is in the third quadrant. So here, we're on the inside of this, 5 pi over 4, and the cosine is the x-coordinate, which is negative square root of 2 over 2. So here we have negative square root of 2 over 2. Then we want to find the cosine of pi over 6. So we go to our unit circle. Here's pi over 6. And the cosine is the x-coordinate, which is square root of 3 over 2, which I put here. And then again, for the sine of 5 pi over 4, 5 pi over 4, the sine is the y-coordinate, which is negative square root of 2 over 2. We want to find the sine of pi over 6. Go to our first quadrant. Here's pi over 6, and the sine is the y-coordinate, which is 1/2. And then I'm just going to multiply. So we've got negative square root of 2 times square root of 3 is negative square root of 6. 2 times 2, 4. Negative square root of 2 times 1 is negative square root of 2. 2 times 2, 4. I have like denominators, so I put everything over a common denominator. So my final answer will be cosine of 5 pi over 4 minus pi over 6 is equal to negative square root of 6 minus square root of 2 all over 4. Now we can check this on our calculator. See, well, that was the exact value. If you put your calculator in radian mode and you find the cosine of this difference, you're going to get approximately this. Then just put this ratio into your calculator. You're going to get approximately, you see the same thing. So that's how you can check it using the calculator. But remember, when it says exact value, you have no decimals when you do that. Let us look now at the sum formula for sine. So it's the sine of the sum, you see the addition of two angles, alpha, beta, will be equal to the sine of alpha times the cosine of beta, plus the cosine of alpha times the sine of beta. Then the difference formula for sine, see difference subtraction. Sine of alpha minus beta equals sine of alpha times cosine of beta minus cosine of alpha times sine of beta. So let's look at an example of this. This time, you notice at 75 degrees, we want to find the exact value. It is not on our unit circle. And if we want the exact value, then we're going to be using our unit circle. But we can write sine of 75 degrees is the same thing as the sine of 30 degrees plus 45 degrees, because 30 degrees plus 45 degrees will give you what? The 75 degrees, which means that we can apply the sine sum for the two angles. See, I rewrite it. Alpha is 30 degrees this time, and beta is 45 degrees. So wherever alpha is, I put 30 degrees. Wherever beta is, I put 45 degrees. Again, alpha is 30 degrees, and beta is 45 degrees. Then you go to your unit circle, and you're going to find 30 degrees. So here we are, 30 degrees. And let me turn it so you can see it. 30 degrees in the sine of 30 degrees you see is a half, which is a y-coordinate, which is what I have here. I go to 45 degrees, it's in the first quadrant here. And our cosine, you see, is what? Square root of 2 over 2, which is what I have here. Then the sine of 30 degrees, go back, sine of 30 degrees is going to be what? The y-coordinate, which is what I had. Well, this should have been the cosine of 30 degrees. Let me go back. Cosine of 30 degrees, which is going to be what? Square root of 3 over 2, which is here. And the sine of 45 degrees, again, here's 45 degrees, and the sine is what? The y-coordinate, which is square root of 2 over 2. And then I'm going to do the arithmetic. And 1 times the square root of 2 is the square root of 2. 2 times 2, 4. Square root of 3 times square root of 2 is square root of 6. 2 times 2, 4. I have like denominators, so I put everything over a common denominator. And I end up with the sine of 75 degrees will be equal to the square root of 2 plus the square root of 6, all divided by 4. And we have applied the sine sum identity. And again, we can check this on our calculator. Put your calculator in degree mode and find the sine of 75 degrees, and you're getting approximately this. Put this ratio in, and you're getting approximately this. So you can do it, check it, on the calculator like that, looking at the decimal. But when it says exact, remember, no decimals for an exact answer. Let's look at another example. It says simplify the given expression. And here I have the sine of 2x times the cosine of 5x minus the cosine of 2x times the sine of 5x. Well, we have to find something, either the sine sum or difference or the cosine sum or difference, to see which one matches up. You see I'm matching this side up, and this side right here becomes the sine of alpha minus beta. See, the sine of alpha minus beta. So the alpha is 2x and the beta is 5x. So we come down here, we're going to replace the alpha with 2x and the beta with 5x. When you subtract, you get a negative 3x, so sine of negative 3x. We're going to apply our even odd identities, so the sine of a negative 3x is the same thing as negative sine of a positive 3x. So that was another way of looking at another type of problem. And remember that when we are doing these videos, remember to stop, rewind, review. Stop, rewind, review. And my love goes out to you.